You're listening to the Common Descent Podcast. Hello, Will.
Hello, David.
Hello, listeners, and welcome to episode 106 of the Common Descent Podcast. Hey, this episode will come out on February 7th.
It does.
Which is the beginning of the week that includes February 12th.
Uh-huh.
Which is Darwin Day.
Oh, yeah.
Happy Darwin Day to everybody, and we have sort of a tradition with Darwin Day that started with our Darwin episode.
It's one of our many traditions.
In 28, of doing historical people of interest. We've done Darwin, we did Wallace, we did Mary Anning last year.
All cool people.
This time around, we are talking about Franz Nopcsa, who probably less heard of than our previous three. Heard of enough to be requested for the episode. Nopcsa is a really interesting character from the turn of the 1800s into the 1900s. Early paleontological theorist, also did research in geology, in cultural studies, named a bunch of dinosaurs, named a bunch of other prehistoric animals. So it's a name you see come up. And I've heard it suggested that this person doesn't get nearly the amount of attention that he deserves.
Yeah, I had heard the name, but I couldn't have told you anything about the person behind the name.
Same.
So I'm very eager to learn.
Well, yeah, I've been doing a deep dive into the life and works of Franz Nopcsa, and it's a really... This is a person whose scientific history is really interesting, and then just all around is a fascinating person. There are so many stories about this guy, and I'm not convinced that half of them are true.
The most interesting paleontologist in the world.
He kind of is the most interesting paleontologist in the world. So it'll be a really cool... we'll talk about where he came from, how he got his start in paleontology, what he did, what he contributed in the early days of the field, and we'll talk about a bunch of just the wacky stuff that he did over the course of his life.
The wacky misadventures of Nopcsa.
It's a lot of fun. This episode was requested by two of our listeners, Andrew and Milu. Thank you both very much for this. I've had a ton of fun learning about this, so I'm excited to talk about it.
I feel like this is a really great example of why getting requests is so awesome.
Yeah.
Neither of us would have ever gotten to this topic.
Perhaps not.
Without either hitting a point of like, all right, I guess we start Googling paleontology and seeing what we didn't do, but having people request it is so much better.
So keep these requests coming in. If there are other people, there are not a lot of people on our request list to do episodes like this. And if that's the case, maybe our tradition won't, we'll just taper off at some point.
It's just remain the idea of a tradition.
But if we keep getting requests, we'll keep doing them. Now, before we get into the meat of this episode, a few announcements. First and foremost, as always, we have a Patreon. And if you donate to us on Patreon, we'll be super happy about it. And we will reward you with some rewards, including bonus audio, including extra... We do director's notes these days after each episode. But also, if you join us on Patreon at a certain level, we'll say your name in gratitude right here on the podcast.
Could you give us an example?
Sure. I might say something like this. Welcome to our newest patrons, Colin, Megan, Finn, Habib, and Anna.
Welcome, everyone.
Thanks for joining us. We really appreciate it. And, believe it or not, that's our announcements for this episode. We're off to a slow and steady start to 2021. We have ideas in the works. We're planning out what's going to come up the rest of the year, so there will be more exciting announcements later on in upcoming episodes. But for now...
Yeah, for now, we're pretty good to go.
We're good to go, and what we go on to is the news. Every episode we like to start, before we get to our main discussion, with some discussion about news. Paleontology, evolution, biology, the kind of stuff that fits the theme of the podcast. Will, start us off with our news.
Happily. This is a bit of news about a pristinely preserved Parasaurolophus skull.
Ooh.
Those long-crested, duck-billed hadrosaurs that are oh so famous, this is a very detailed specimen that has revealed new info and new insight into this group.
I'm excited already.
This research is by Terry Gates et al. And is published in PeerJ. And the article is a press release by the Denver Museum of Natural Science, inphys.org.
Cool. And the link will be on our blog that we always have.
Yep. So one of the first exciting things about this is, according to the press release, this is the first new Parasaurolophus skull discovered in almost a century.
Wow.
Which I didn't realize that was the case.
Huh. I mean, this is one of the old school famous dinosaurs, so it doesn't surprise me that the discoveries go back very far.
Yeah, the history makes sense.
But no new skulls.
The gap is what surprised me, and I guess it means that a lot of the inferences and insights we've been making have been on a select few early discoveries that we haven't really gotten to update until this discovery. So that's part of the reason it's so exciting. They said it's very well preserved. It has the inside of the crest, which is the nasal passage. The nose basically boomerangs back over the head in a big U-turn.
Yep. And that crest in some specimens can be like 6 feet long behind the head.
And this is not one of those. This has actually a much more modest curved crest.
Okay.
But the nasal passages inside have preserved, so they've gotten to get a good look at the inside of its crest.
Very cool.
And hopefully it will help put to rest the almost century-old debate of what were they doing with that crest.
Right. Were they displaying? Were they bleating? Was it their head trombone?
Which we talked a lot about in the Paleo Noises episode.
Yes, we did. Episode 52.
And there's been lots of wacky ideas as well, that it was like a snorkel or something like that. Like it's such an extreme feature that it was hard to agree right away on what it does. Nowadays the general consensus is that it was a noisemaker, and this research so far has not overturned that. It seems that it looks like a resonating chamber for making deep trombone noises. But they do make the note that it's an extreme nasal passage, which means if this animal is breathing through its nose, one quote was saying that it means the oxygen will have to travel 8 feet before it actually gets to their lung.
Wow.
So it's just such a weird feature. There are 3 species of Parasaurolophus recognized currently. They range from Alberta, Canada to New Mexico, and are found in rocks dating around 73 to 77 million years old.
Late Cretaceous.
The new skull belongs to a species known as Parasaurolophus cryptocristatus, which was previously only known from a single specimen collected in New Mexico, same region this one came from, but in 1923.
Wow.
So they meant literally almost a century. Like, give us a few more years and it would have been.
Yeah, but it was discovered during the life of the person we're going to be talking about in this episode.
So this is a very exciting find. We are doubling this species material after nearly a century. Both display a shorter, more curved crest, so not the long, gently curving crest, but a more like banana-shaped.
Right.
Which, they do note, we have 2 specimens that could be a sign of immaturity at death.
Right, that they're not fully grown, and so their crest isn't fully developed.
It might have, through ontogeny, through individual development, become an adult crest that was more elongated or less curved or changed in some way. So we still can't say for sure that that is their normal adult crest. The specimen is not complete, even though the skull's in good condition. They said there's abundant bone fragments around where the specimen was found that indicate...
Smushing.
Yeah. That it was likely preserved in an ancient sandbar, but now, and was probably more complete at one point, but now only the part of the skull, part of the lower jaw, and a handful of ribs have survived the erosion of this ancient sandbar. But it looks like it would have been living in lowland floodplains based on the rocks it's preserved in. And like I was saying earlier, one of the big exciting things is that they can really get a look at the inside of the crest. The bones inside have been preserved in enough detail to start doing some of that research that will really solidify what they were likely doing with it. And may hopefully help with solidifying, as they put it, the validity of certain species.
Gotcha.
That we may now be able to start locking in that one of the features of this species is this structure of the crest.
Right.
And so this could add another detail for identifying this versus other, hopefully future findings of Parasaurolophus.
In another 100 years.
Yes. It also is showing signs that it may slightly rewrite some of our understanding of the Parasaurolophus relationships between species.
Okay.
So the family tree of Parasaurolophus basically has the two long straight-crested species, Parasaurolophus walkeri and Tubuson, and had them more closely related despite the fact that they are found about 1,000 miles apart and separated by about 2.5 million years in the aged rocks that they're found in. But that's the traditional grouping, is that they were more closely related. Additional analysis of the skull, excluding the crest of this specimen here, suggests that the more southern species, which means like New Mexico to Utah, so like not Alberta,
right,
may actually be more closely related than the northern species.
Gotcha.
And so if you don't look at the crest and look at the skull of this new specimen, it's indicating that the relationship may not be so clear-cut as straight crests go together.
Right.
Which fits the patterns that we observe in other dinosaurs of that age in those localities, like horned dinosaurs split up a similar way, with southern and northern species being more closely related to each other respectively.
Okay, makes sense.
So, a cool Parasaurolophus that hopefully will open lots of doors into our understanding of them. This is still, the early stages.
It's always fun to get new specimens of a well-discussed dinosaur taxon, a species, because then you get to revisit some ideas that have been in the books forever.
Mm-hmm.
But I have to say that the thought that's been stuck in my head since you said it is you mentioned that they suggested that the shorter crest might be a juvenile feature.
Yeah.
Which made me wonder, did the juvenile sound different?
Almost. They would have to, right? Like, if I shrink down a tuba, that changes the sound.
So did they have like little the sound in my head is the sound in the Jungle Book during the elephant's marching song when the baby elephant tries to trumpet?
Yes.
Yeah. Are they all like have these squeaky horns?
it's the adults all sound like tubas and the babies all sound like trumpets with mutes on.
Yeah.
Well, the other reason I really appreciate this is, as both of our reactions showed, I wasn't aware that we've had such a dearth of discoveries with such a famous dinosaur.
Yeah.
And I feel like that can happen very easily because, we all know Parasaurolophus. It's such a famous dinosaur. But actually, it's a very poorly discovered. Like, we have not discovered as much of it as its fame would make you think. And so having a discovery like this come out and go, actually, lots left to learn.
Yeah.
This is not, just because it's famous doesn't mean it's super duper well understood.
Yeah. Yeah, so I'm excited to see what more comes out of this.
Very excited.
Well, speaking of a lack of fossils, my first bit of news is about a group of animals with an extremely poor fossil record. Predatory polychaete worms.
Oh, I believe it.
We've talked about these a bunch of times before. They'll often go by the name bobbit worm.
Yeah.
Although the article we'll link to uses the term sand striker worm.
That's so much better.
Which is so much better.
Oh, I'm not calling them bobbit worms ever again.
For all the reasons, that is so much better. This is research that reports the apparently first potential fossilized burrow of a sand striker worm.
Ooh. This
is research published in Scientific Reports by Yuyen Pan et al., and we will link to an article in National Geographic by Riley Black. Eunice aphroditois, the sand striker worms of today, are polychaete worms that live in the sea, and they have the extraordinary habit of burrowing into the sand with their heads just under the surface of the sand. And then when a fish or a crab, or let's be honest, whatever they want, comes by, they have these giant bear trap jaws.
That, unfold out of the mouth. It's not just that they open them, it is invisible in the mouth and then unfolds out.
And they reach up, snatch the prey, and drag it down into the burrow like a actual horror movie monster.
Oh, and the videos for it are so perfect. It's there. grabs the fish, and then a swirl of sand and gone.
And it's gone. These are found in shallow marine environments in the Atlantic, the Indian Ocean, the Pacific Ocean. They're all over the place. They can be up to 3 meters long, 10 feet long, and up to 2 centimeters across.
Whoa.
An inch.
Yeah, 3 meters doesn't mean girthy.
No, they're ribbons.
This is a ribbon.
They're death ribbons.
A murder ribbon.
Adults construct permanent burrows in the sand. So these aren't like burrows that they're digging while they're there. They are a permanent
that they've constructed.
House for them. And they'll line the sides with mucus to keep the structure so it doesn't collapse. But of course, most of this worm is soft tissue. So very little fossils are known. There are fossilized jaws from worms like this going back to the Silurian 400 million years ago. But very little body fossils and no known trace fossils of predatory worms. There are polychaete trace fossils from deposit feeders, detritus feeders, filter feeders, but not carnivores, not predators.
Because polychaetes run the gamut of lifestyles in the ocean.
Yes. This new research reports trace fossils from the Miocene deposits, about 20 million years old, in northeastern Taiwan. The fossils, the trace fossils, are L-shaped burrows preserved in the ancient sediment, over 2 meters long.
Ooh.
Each. There are a number of them. So over 6 feet long, 3 centimeters in diameter. So fitting the size and shape we're looking for. And, according to the authors, unlike any other trace fossil known. So they took a closer, right? It's got the right shape, it's got the right size. Mm-hmm. They took a closer look at the top of the burrow and they found a couple of things there. One is that the top of the burrow shows signs of repeated collapse with these feather-like impressions in the rock that seem to suggest rapid movement in and out of it.
Yeah, that the entrance is being used quite regularly and potentially violently.
Yeah, and they say that. They say this wasn't like a slow crawl in and out. This was a violent movement in and out of the top of the burrow.
That's really cool.
And they found that the sediments around the top of the burrow were rich with iron, which they suggest is produced by bacteria that produce iron sulfide as they live there, feeding on the mucus that these worms would have used to reinforce the top of the burrow.
Weird.
How cool is that?
Wow. That's like, wow.
Those are the kind of moments where the relationship between paleontology and forensics is very notable.
Yes, we were able to determine this was a sand striker worm because of the scratches on the back of its watch.
Yes, yeah, exactly.
I love it. That's such an obscure note, but actually very good evidence.
Yeah,
if that is accurate. Wow.
And then, of course, they gave it a new species name. As we've mentioned numerous times before, Ichnotaxa, so trace fossils, get their own names because they can't get the same name as a body fossil.
Yeah, unless we have the body in the trace fossil.
You can't name a footprint Tyrannosaurus rex because you don't know it was Tyrannosaurus rex. You just name it Tyrannosaurus foot or whatever. In this case, they designated the new ichnogenus and species Penicnus formosae for the seemingly first known 20 million year old sand striker worm burrow.
Very neat.
How cool. Cool fossil, cool research, cool animals.
Yeah. Oh, and I love the way that the evidence that drew them to that conclusion is very cool evidence because, you know, I'm not, a burrow is not a burrow, but lots of things make burrows.
Right.
You know, that a burrow is not unusual in and of itself. And using mucus to reinforce a burrow, also not that super.
I can't imagine they're the only ones.
No, lots of things use their secretions on their burrows. But the fact that it's like this is a burrow being used, it seems, in a way fitting this lifestyle.
Yep, it's the right size and shape.
Mm-hmm. I like that. This is a really good example of we did not just find a thing that screamed sand striker burrow. Mm-hmm. We found a burrow And then each extra bit that we noticed kept narrowing it down until it sure does seem like it's a good fit.
Yeah.
And that's really cool.
Including evidence of sand striking.
Yes, exactly. Like, I like that a lot.
It's real cool research.
Very neat. I want us to find out more about these awesome worms.
Get on it, worm paleontologists.
Well, my next bit of news is about some research that takes a look at the early domestication of dogs and links it to Siberia.
Ooh.
So this is some DNA research that falls on one side of the argument about early dog domestication.
We've talked about dog domestication a couple times, episodes 27 and 94, and there are just so many questions open about it.
Because it's messy. It did not happen in a orderly... It happened kind of all over the place, it seems. Maybe. This is research by Angela Perry et al. In PNAS, and the article is by David Grimm in Science Magazine. So, toward the end of the last ice age, there were humans living in northern Siberia with some of the world's first dogs. It's like, there were people with dogs by that time.
Right.
And the descendants of these people spread out both east and west. And some of them went to, populating Eurasia, and then others came here to North America. And it seems brought their dogs with them, which became the first dogs in North America, which is where some of our earliest information about, dogs and stuff comes from. So they wanted to look into what is the story between this connection, and can we find out any information looking at dogs and the DNA of both dogs and humans in these locations to see if the spread and splits match each other, to see if indeed the domesticated dogs we're finding in North America were brought here or were they secondarily domesticated.
Right.
Because that's one of the big questions is, were there multiple events of domestication, or were they domesticated and then spread with humans? And so we're going to compare dog DNA and human DNA and see if we find similar patterns of spread and splits.
Cool.
Yeah.
This makes me think we discussed in episode 99, and I think in 102, about tracing parasite and host evolution, that they sort of match each other. It's like that, but with domesticants.
Yes, exactly. So this is aiming to try to help settle that debate of where and when were they domesticated, and were they domesticated more than once, and what is the pattern of their spread if so. But they do note early on in the article that more genomes will be needed to actually confirm these early findings. This is not definitive by any means. So the genetic and archaeological evidence suggests that domesticated dogs have lived in North America for at least 10,000 years. And so by looking at genetic data through this history and comparing it with human genetic data, basically they're going to look for where do we see them start to sync up and confirm that, they're domesticated, they're with us, they're traveling with us. They analyzed previously sequenced mitochondrial genomes, so from the mitochondria, not our nucleus, the dog's nucleus, of more than 200 dogs from all over the world. Some of these dating back to 10,000 years old. And they found an interesting similarity between them all in that they all carried a genetic signature they dubbed A2B. And this allowed them to map certain things within this genetic analysis. They found that it seems they split into 4 groups about 15,000 years ago as they started to populate different parts of North America. And the timing of these splits does seem to mirror ancient Native Americans that would have come from those ancient Siberians, which would seem to suggest that indeed when the descendants of ancient Native Americans came over from Siberia about 16,000 years ago, they were entering America with their dogs.
And then as they spread, their dogs diversified with them.
Exactly. Now, an interesting note about these ancient dogs is eventually those ancient domestic dogs vanished. Those aren't around anymore.
Right, we've talked about this, I think, in previous news stories, that there were ancient American dogs that don't seem to be the same dogs we have today.
Exactly. And especially with the domestication story, it may have been partially due to when Europeans brought their domesticated dogs over.
Right.
And that's now the dogs we have here. So that is an extinct lineage of domesticated dog, it seems.
Right. How weird is that?
Super weird. They also found that the A2B gene descended from a canine ancestor from Siberia that likely lived about 23,000 years ago, potentially living with, or near those ancestors of these early Native Americans. And it seems that it lived in a relatively temperate part of northeastern Siberia, so not frigid tundra, where also in that area it would have been sharing space with gray wolves, which are the ancestors of domestic dogs, so that tracks. And could be maybe potentially part of the story of how dogs became domesticated.
Cool.
So we've talked about that the current general agreed upon idea, or the popular idea, is that dogs living near humans were attracted by our scraps or our kills. Were attracted by the food we were having in enough abundance to be tempting. And the less timid or less shy or less, or more friendly, you could say, ones started approaching closer and closer, and over generations started to either get fed by us or encouraged to come closer by us, until eventually we formed a relationship.
Right, now we're
with
working
these canines
together.
And then they were domesticated. If they were in this kind of oasis in Siberia, that could have encouraged a closer interaction. If we can't really spread out from each other, because that's one thing they mention, is that hypothesis of domestication doesn't really work if the humans are migrating, if they're nomadic, leaving all the time, and they're interacting with, they're not able to consistently interact over generations.
Interesting.
That if we're kind of closed into a fairly small region, that could encourage that relationship more readily. Potentially.
Yeah.
This is a hypothesis. This is very hypothetical. This evidence also potentially helps explain why it seems that domesticated dogs show up in both Europe and North America about the same time, 15,000 years ago, which is part of why there's the hypothesis that there were multiple events of domestication, is we have these seemingly simultaneous histories. But if they both spread out from this central location, it could support a single domestication event.
Right. That they weren't necessarily domesticated in those places at the same time, but they arrived in those places at about the same time.
Because the people spreading out, or because of trade between people who had already spread out and were now interacting, because there is signs of interbreeding between the ancient Siberians and early Native Americans before they left.
Okay.
So they could have given them dogs, basically.
Yeah.
Here's this cool animal we made. But not everyone is cool with this research.
Of course.
And some people are basically discrediting it completely. There are some people who don't put any weight into it. One person that was quoted, Peter Salvalainen, is quoted saying that the A2B signature that was so important in this research and was claimed to be exclusive to the American dogs is found elsewhere, is not as exclusive as the research made it seem. So it's not as focused a connection, potentially. So therefore, if that's the case, as he put it, it invalidates their entire genetic analysis.
Sure.
So there are some people who basically are not only questioning or disagreeing, but throwing the whole thing out.
Yeah.
So this is very early. This is not putting to rest the debate of dogs.
Yeah, it's interesting because it's the kind of study that relies on our DNA evidence from dogs and from people, which is constantly shifting and updating, and we're always getting new information. So which is why this story keeps changing.
Yes.
Slightly here and there as we keep getting better and better info.
And they do make the point in the article that they're using mitochondrial DNA really until they get genome, genetic DNA from the animal cell.
Right, the nuclear DNA.
They won't really be able to fully piece together this story.
Mm-hmm.
And so they do admit that, yeah, we're not using the ideal
Right.
DNA.
There's more DNA for us to examine.
Exactly. And you may not always have that DNA. So there's lots more work to be done, but it is a potentially a new way to answer the question of how, when, and where did dogs become domesticated.
Very cool. Well, keeping with our unintentional trend, sometimes it's on purpose, this time it's not, of moving forward in time with our news stories, my next bit of news is not about things that happened millions of years ago or even thousands of years ago, but a few decades ago, but revolves around questions of extinction and environmental change and how animals deal with those kinds of changes. This is research that examines what has happened on the Philippine island of Luzon after Mount Pinatubo erupted.
Oh.
Yeah, this is research by Eric Rickert et al. In the Philippine Journal of Science, and we'll link to a press release from the Field Museum on phys.org. In June of 1991, Mount Pinatubo blew up.
Mm-hmm.
Major volcanic eruption, one of the biggest volcanic eruptions of recorded human history. Pulling some stats from the report and the article, about 800 people died as a result of this eruption, and the height of the mountain dropped 250 meters, replaced with a caldera. A mountain exploded.
Yeah.
Major eruption, and the forests in the island, central Luzon, were largely damaged, largely destroyed thanks to ash, pyroclastic flows, and then years of mudslides when it rained on the unstable landscape now. Beforehand, there was a lot of old-growth forest on the slopes of the mountain. So, forest that had been around for a while that was in late stages of forest succession. Basically, an old forest.
Yes.
But, more recently, after the eruption, now that vegetation, that forested landscape, is characterized by new growth, which basically means the forests were destroyed and are slowly rebuilding what a forest will eventually look like. Which has raised lots of questions of what happened to all the animals living in those forests. So this study did a survey. They actually did the survey in 2011 to 2012. So 20 years after the eruption, they took a survey of the mammals of this region. There have been previous studies on this island that have looked at the difference between old-growth forests and disturbed forests. Usually disturbed by human activity, usually near croplands and stuff like that. And what they found is that old-growth forests have a lot of native species that are from the area, and very few non-natives like pests, rats and stuff that have been introduced. Whereas disturbed areas tend to have lots of non-native species, so introduced rats and stuff, and very few native rats and plants and other animals and things. That when the forest gets disturbed, the locals tend to disappear or shrink in abundance, and new introduced stuff gets a foothold.
Huh.
So in this study, they were trying to see, okay, are we going to see a similar pattern? And they were especially interested in the fate of one species, Apomys sacobienus, the Pinatubo volcano mouse.
It sounds like it should be fine.
Right? It's a fire type.
It's what you're named for.
This species is previously, before this study, only known from the holotype, a specimen that was captured on the mountain back in the 1950s. And because it was so rarely known, it was thought, all right, it's probably rare, possibly only lives here, and rare and regionally restricted species tend, we think, to be pretty susceptible to disturbance and extinction. And no one has seen it since, so they were thinking, part of the question going into this is, do these mice still exist?
Yes.
And indeed, part of this survey, they looked at other nearby mountains and did not find this species. So it seemed this is a species that is endemic to Mount Pinatubo,
Which just blew up.
Which just blew up, absolutely. So in this study, they surveyed the eastern slopes of the volcano, where the plants were devastated and have slowly been regrowing. The vegetation in that area is a mix of native and non-native plants, with lots of low plants, so shrubs and vines and stuff, and not a lot of trees, which is what you'd expect to see from a regrowing forest. Mm-hmm. They particularly were looking at mammals, and what they found were 8 species of bats, 7 species of rodents, and 2 large mammal species, specifically wild pigs and deer. And they point out that some of the bats and large mammals probably moved in from nearby areas shortly after the eruption of the volcano. They also make the point that there's an unusually high diversity of fig plants in the survey location, which might be thanks to the fruit-eating bats and birds
that just moved in.
And are carrying these
and
seeds.
Pooping all over the place.
Yep, carrying the fruits with them.
That's fantastic.
But the big surprise, well, the first big surprise, is that most of the rodents they found were native species. Mm-hmm. Species from that area already, and there weren't very many introduced pest species, right? New rats or mice from outside, which is unexpected.
Yeah, that's the opposite.
Even though this whole place blew up, a lot of those species are still there. And the next big surprise, the most abundant and widespread species of rodent that they found
was not the...
was indeed the Pinatubo volcano mouse. Not only were they not rare...
were they not extinct?
They're doing better than everything else in this area, it seems.
Well, I assume by the name they feed on volcanoes, and now
That's
they have
it made them stronger.
extra access to their food now that it's all opened up.
I've seen Godzilla. So the authors point out that the endemic species of Mount Pinatubo are specialists with restricted distribution, but are still able to tolerate disturbance and resist invasion, as they put it, by non-native species moving in. That they're really good at holding on to their habitat even after disturbance, and they make this incredible point, which I will quote. I'm pretty sure what I wrote down here is the direct quote. Among Philippine mammals, Apomys saccobianus, the Pinatubo volcano mouse, is perhaps the most extreme example of a disturbance specialist, a range-restricted species that is highly adapted to life in a landscape that is periodically ravaged by catastrophic events.
Yeah, because, I mean, this isn't the first time they've had to deal with the volcano being a volcano.
No. You live on a volcano. That's what they do.
Yeah, and you're good at dealing with it.
So we may have found here in this area an ecosystem that specializes in rebounding after the world falls apart.
That's move aside cockroaches as everyone's go-to example for the post-apocalypse. Pinatubo volcano mouse.
Volcano mice. Which has a lot of interesting implications for what it means when rare species suffer habitat destruction. Mm-hmm. What does the future of the Pinatubo area look like? Because it's not done rebounding. Yeah. Right? This is a decades-long process at least. So this could be a really cool area to learn about post-catastrophe ecosystem behavior. Mm-hmm. Which, of course, is exciting, A, for modern conservation, and B, for paleontology to know, okay, yeah, we found evidence of this disturbance in an ancient habitat, but that might not necessarily mean that everything died there.
Exactly.
Especially since, if this research is to be understood, there are specialists
for dealing with
that, which is very, very cool.
Well, and I like it. There's two cool things that jump out of my mind here. One is the fact that we, didn't just fully assume, they went and checked it out, but that, we had a specimen from a long time ago, and then no one's ever seen it since.
Yep.
Yeah, that doesn't mean for sure anything.
Oh, yeah, we could have just missed it. Also, I don't know if anyone had gone looking before this study.
Exactly. Like, how many people have gone out looking for the Pinatubo volcano mouse?
Right.
Are there Pinatubo volcano mouse tours? Like, a piece of data does not mean there's only a piece of data.
Yep.
And so I like that example of once they went looking, the story was completely different. But also, it's a flip on the head of typically how the story of specialized animals go. Like, so often we talk about the fact that during cataclysms, during extinction events, the more specialized you are typically means the worse off you are after it.
Right. The more specific your needs in terms of food or habitat, the more likely you're going to lose everything you need in this catastrophe.
Exactly. But there are flip side examples.
There are exceptions, apparently.
Where you could be so specialized that you're specialized at surviving the things that would cause extinction.
Yeah. Well, it brings to my mind the plants that require forest fires.
Yes, exactly.
To then complete their sort of long-term cycle of regrowth.
Mm-hmm. And so it's just a fascinating example to kind of resettle the way you think about stuff and make you take a step back and go, okay, well, if this is true, where else might that be true? Where else might that example kind of show up? And I love it.
And I think possibly my favorite thing about it is that the animal that is teaching us this in this study is a little mouse.
Yeah.
Which is fantastic. An unassuming face of catastrophe.
Yeah, that's turning its nose up at a volcano.
Well, with that, let's bring the news to a close and move on to our main event. Go back a little bit farther in time to the late 1800s and discuss the life and works of Franz Nopcsa after the break.
Let's.
Baron Franz Nopcsa von Felso-Silvas.
He's a baron?
He's a baron.
Oh.
Well, he was a baron. Now, I'm not going to say the last part, von Felso-Silvas, again in the episode, because I don't know if I'm saying that correctly.
Yeah.
I have reason to think Franz Nopcsa is how you actually say the name. Baron Franz Nopcsa is a figure in the history of paleontology who is discussed, according to some, not nearly enough for his contributions to the field. This is a fascinating person. He is known for being an innovative and successful scholar. He was a researcher of paleontology and geology, of cultural studies. He traveled around doing all sorts of research. I've heard him described as charming and fashionable, also as arrogant and competitive. This was a person who was at the time and still is remembered as this renowned scholar whose life is made that much more interesting by the fact that it also includes, but is not limited to, tales of him riding his motorcycle across thousands of kilometers of Eastern Europe with his boyfriend in the sidecar looking for cool geologic formations and stuff, acting as a World War I era spy, trying and failing to become the king of Albania, and his death, which was much reported and given much attention at the time for being a murder-suicide.
Whoa!
This person's life is a disappointing movie waiting to happen.
Yes.
This is a fascinating individual. So let's back up. That's the teaser. That was the trailer for the next hour of discussion. Let's set the stage of where we are in relation to our study of interest. Nopcsa lived during the last few decades of the 1800s and the first few decades of the 1900s. This is a time where dinosaur paleontology is really just getting its start. Europe didn't have a ton of dinosaurs known just yet. North America was getting a lot more dinosaurs. Nopcsa was born in 1877, which is during the Bone Wars.
There you go.
That we talked about back in episode 58. So this is the time of the earliest sort of famous North American and European paleontologists. This is a time where paleo art is about getting its start. People like Charles Knight, who are really coming into prominence in the early 1900s, depicting ancient creatures. We talked about Charles Knight a bit back in episode 64 with Gabriel.
Yup.
And the study of evolution is coming into its own. Back to episode 56. Darwin released his famous book in the late 1850s, but then it took several decades of much more science going on to come to the sense of evolutionary science as we know it today.
Yes.
All that is happening at the time that Nopcsa was alive. That's the setting we're in. Paleontology, particularly dinosaur paleontology, and evolution as we know it are all sort of coming into...
Coalescing.
Coming together to a recognizable form. And into this interesting period of time comes the Baron Franz Nopcsa. Born in 1877 in Deva, which was formerly in Transylvania, part of the Austro-Hungarian Empire, but now is part of Romania.
Oh, okay.
Yep. He was born the son of Hungarian aristocrats, so he was a Hungarian by ethnicity. They were a wealthy, noble family. Unfortunately, according to the sources I've read, a lot of the information about that family has been lost, so we don't know a lot about their history or what they were doing. The reasons it was lost will become clear later. As Nopcsa grew up, he was educated at the University of Vienna, and he studied geology. And it was during his time at university that he got his first taste of paleontology. In 1895, when he was around 18 years old, as the story goes, he was walking around the family estate. They were wealthy, so they owned a whole bunch of land.
So they had an estate.
They had an estate. Walking around the land with his sister Ilona, where she found some strange-looking rocks and presented them to him. He ended up sharing them with a professor at the university, Edward Seuss, who said, those are dinosaur bones. But people don't know very much about those, so go research them. So he did. He went back to his estate, where he, of course, again, this was an estate, had a library and tons of books.
I'm pretty sure you can't be an estate without having a library on, I'm pretty sure that's required.
Right. Well, this is like what the Beast had.
Exactly.
You don't have to use it, but it's there.
Yes.
So he read all these books, he gathered all this information, and spent several years teaching himself about paleontology, anatomy, physiology, at his home, Sachel Castle. Like a lot of the early figures, we talked about Darwin back in episode 28. A lot of the early figures in the pioneering days of modern science were rich people because
who else had time to do science?
Right, you didn't have to work. You could do whatever you wanted all the time.
Yep.
So Nopcsa ended up teaching himself paleontology. He didn't study it at the university because back then there wasn't really much opportunity for this to be a career path. They didn't offer classes and majors in paleontology really back at this time. He taught himself the information about paleontology, biology, geology, also how to search for fossils and excavate and prep fossils. So he spent some years traveling around his own part of the world collecting fossil remains. And then in 1899, at the age of 22, he gave his first lecture. At the Austrian Academy of Sciences in Vienna, he presented a lecture called Dinosaurs of Transylvania.
I like that title.
Yeah, where he introduced his findings, what he had been seeing around his Transylvanian home, including presenting a new species of hadrosaur from the bones that originally he found with his sister. That turned out to be the skull bones of a new type of hadrosaur.
That's cool.
How cool is that story?
That's a good origin story.
He originally named it Limnosaurus transylvanicus, but later renamed it a few years ago Telmatosaurus because Limnosaurus was apparently taken by a crocodilian.
Hey, yeah, move out of the way. Also, kudos to him for not naming it after himself.
Good job.
Back in that day, I half expected.
Don't think he ever named anything after himself, but he did name something after somebody else at one point, which is a story I will tell later. Telmatosaurus transylvanicus is a name still in use today. And indeed, he ended up naming a lot of things that are still in use today. Over the course of his career, he named 5 dinosaurs and about 25 other reptiles in fossils. Nice. And a lot of those, some of them have had the names changed over time, but a lot of them we still use today. Also in that first lecture, in addition to introducing dinosaurs of Transylvania and here's this new hadrosaur, he also apparently, based on what I've read, which I'm going to say that sentence a lot. Yes. There are a lot of stories about this guy.
Well, that's whenever you have a popular historical figure who is also an extreme historical figure. Eccentric historical figure. People want the stories to go the way that you'd like them to.
So keep in mind that most of what I'm reciting is I found on tertiary or secondary sources.
Yes.
And honestly, even the primary sources, we have the term unreliable narrator.
I was about to say, it's like straight from his personal journal, where he talks about the bear he fought to a standstill.
In that same lecture, he also harshly criticized the existing idea of dinosaur taxonomy and proposed revisions.
Oh.
To say, yeah, no, this is how it should be. Which brings me to his personality. I have read a lot of descriptions of the kind of person he was. Many places I've read him referred to as a respected scholar. Ultimately, as he got older, became a respected scholar of paleontology and geology and other things. I've seen him described as ingenious and innovative and interdisciplinary and really ahead of his time in many ways. I've also seen him described as arrogant, not great with people. One article that I read described he had a, quote, talent for rudeness. Some of which, he was rich.
Yes, exactly.
He was a baron, so I guess that's kind of...
Is he nice?
Yeah,
no.
Yeah, exactly.
Or maybe he is, for his version of nice.
One thing that I read also described that he was sometimes openly anti-Semitic. So that one's not as funny.
Ew.
So he wasn't a perfect person.
Yeah, I like that. It's like no, he was a scholar. He was very insightful and professional in his scientific pursuits. Also generally dislikable.
Yep.
And
so he certainly had flaws. There are a few stories I've heard that seem to be anecdotes to portray the kind of person he was. One story.
This sounds like when you're asking someone like, so what he's like. Well, let me tell you a story.
Let me tell you a story. Well, let me tell you 2 things I read about this guy. One story that I've read in a couple different places, and again, these are stories I've read. I'm sure some of them are based in truth. In 1906, at the Natural History Museum in London, Nopcsa supposedly walked up to the cast of Diplodocus, which had just recently been installed, leaned over it, carefully removed one of the large toe bones from the mount, turned it right side up, and carefully put it back. According to the Baron's later writings, I quote from the article I read, museum officials were not amused. Another anecdote that I read in that same writing, this was a book that described him. I found a bunch of cool resources with information about Nopcsa that we'll put in the blog post. He was also described as charming and fashionable. Mm-hmm. I found in my reading a description of how he dressed at his estate in great detail. This is apparently from Lady Smith Woodward, who was the wife of Arthur Smith Woodward, who worked at the London Museum of Natural History and would correspond scientifically with Nopcsa. Lady Smith Woodward described Nopcsa dressed at his estate thusly: in a gold brocade tunic and a dolman lined with sable skins slung over one shoulder, white buckskin breeches, high shining black boots with gold embroidered tops, sword belt, sword, tunic buttons, all gleaming with glittering gems, and a fur cap with a high egret plume.
So subtle.
Which is really funny, because I also read accounts that people would say that he would... One article I read described him as disappearing for months on end, only to appear at some social event dressed as a peasant. This was a memorable character, by all accounts.
I feel like this was one of those people that if you were a person alive at that time and worked or were in similar circles, you either being a rich person or a paleontologist, that everyone you knew would have a story.
Right.
It's like when you go to business conferences and you're like, have you ever met? Yes, I have. Here's my story of the one time I met this semi-famous person.
Among the various articles and papers I read, I have seen Nopcsa compared variously to Lawrence of Arabia, Indiana Jones, and Freddie Mercury.
Yep. That's kind of what I was picturing, with a little Elton John in there.
Maybe a little bit.
That's the fashion I'm kind of sensing. Yeah. I'm ready to learn more.
Oh yeah, no, that's just who he was. Let's talk about what he did. After he finished school, so he got his PhD in 1903. So we are now in the 1900s, 2 years before T-Rex was named. I always like to throw that little tidbit out there.
Yeah, we didn't know about that yet.
After he finished school, he went traveling, which was not uncommon back then, especially if you're a baron.
Yeah, especially when you can travel wherever you want because you have money.
He spent a lot of time traveling around the Balkans area. So that is, if you picture in your head where we are, Austro-Hungarian Empire, northeastern border of the Mediterranean, right? To the east of Italy, just that whole section of Europe over there. He traveled around Greece studying geology, and then he went to Albania. And though we are talking about Nopcsa in reference to his paleontological background, he is extremely famous in the history of Albania.
Oh.
He traveled to the country of Albania, apparently fell in love with it, spent much of his life there. He lived in Albania for a while. He spent years and years traveling across the northern Albanian mountains. He was one of the first foreigners to do so. He lived among the people who lived in the mountains of Albania. He learned Albanian, the language, which was very rare for a foreigner. He fully immersed himself in the culture and the region of this country.
Yeah, to become as Albanian as he could.
Yeah, exactly. He traveled around with a camera, a Kodak camera, which I found a documentary about him on YouTube that interviewed a few experts, scholars about his history. And one of them points out in the documentary that this would have been one of the first cameras in the region.
Yeah, and also, I didn't know Kodak went back that far.
Yeah,
wow.
apparently.
Kodak and Parasaurolophus.
There you go.
Long histories.
So he traveled around Albania taking pictures. About 150 of his photos still survive today. Wow. And they are stored in a museum, I think in Berlin. He would eventually go on to become a foremost expert on the geology, geography, and culture of Albania. He wrote a lot about the geology, the rocks, the formation of the landscape, languages, folk customs, archaeological information there. Over his life, he published more than 50 articles about Albanian folklife, which remains the basis of modern study of that region.
Whoa.
So, we're going to talk about his paleontology stuff, but also he was an Albanian cultural scholar.
Yeah.
Early on in his travels around Albania, another major life event, in 1906 in Bucharest, he met a young Albanian man named Bayazid Elmas Doda. Doda would go on to end up to travel with him and he would hire Doda as his private secretary, and it is generally agreed by all the sources that I've read that the two were lovers, that this was his partner, that this was his boyfriend ultimately. Which brings us to another really interesting fact about this historical figure, is that he was gay.
Mm-hmm.
Now, I've seen a lot of sources, a lot of articles written about him that describe him as being openly gay at the time, which is surprising.
That's what I was wondering, yeah.
But I've also seen some conflicting information on that. I've seen at least a couple of sources that suggest that he might not have been quite as open as some others suggest, that maybe it was a little bit more reserved, that homosexuality would have been a taboo in that place at that time, especially for someone of high class. Of status. But then on the other hand, I've seen a lot of people laud him as being, openly gay man at this time where it would have been even harder
where that was uncommon
than today. And I've also seen it pointed out that if that was the case, this could easily be another perk of being rich.
Oh yeah, well that's because
you're wealthy and people can't touch you about
That's
it.
what I was about to say is there's the side of saying, whoa, you're a baron, all right, you've got a reputation and there are expectations of you, but also you're a baron.
Yeah, I'm a baron. What are you going to
do? I can pay you not to care.
So there may have been some sort of a liberating quality to the wealth. That same upbringing that meant he could travel around and not ever have to worry about paying for it. Yeah, maybe he also felt like he could be who he wanted to be. However open they were about it, the two men traveled together a bunch. Doda would end up traveling around Eastern Europe with him, helping him study geology. Doda was also a pretty skilled geologist, helped him study the region, find fossils. Doda was the first to discover bones that Nopcsa would later name as another new species, a Struthiosaurus, an ankylosaur,
nice.
A nodosaur specifically. This is where I've also heard it described that the two of them would travel around Eastern Europe in Nopcsa's motorcycle, with Doda in the sidecar and Nopcsa driving him around, and they just travel around Europe together.
I mean, that's if he weren't such, it seems, a jerk of a person, this sounds like a really good kids animated.
Right?
Them puttering around in a motorcycle and sidecar and stopping places and being like, look at that rock outcropping, and then here's the lesson of the episode.
Well, they would look at rock outcroppings and then also get into trouble. Here's a story. Now, this one comes straight out of his memoirs, is a story of how the two of them were traveling around the northern mountains and stayed at the place of a man, Mustafa Lita. I don't have the name in front of me, but I think that was the guy's name, who let them stay at his place and then wouldn't let them leave. And it turns out he was a notorious bandit who had taken them prisoner.
In the guise of
inviting them in.
Yeah.
And then they managed to talk him into delivering them somewhere safe where he was almost ambushed and killed, but then they let him go. Because this was this guy's life, apparently.
Wow.
Another fun story about the relationship between Doda and Nopcsa that brings us back to the paleontology side. In 1923, Nopcsa named a species of turtle after Doda. This was a turtle from the latest Cretaceous of what is now Romania, which he named Calacabotian bayezidi, named after Bayezid Elmas Doda, which means, apparently, beautiful box, referring to the shell, I suppose, of Bayezid, which is cool. And now we get to the part that is another story.
Yeah.
Allegedly, I've seen this referenced in a couple places, but I'm not sure where this information comes from.
Yep.
The story goes that Nopcsa named the turtle after Bayezid because the shape of the shell reminded him of Bayezid's butt. Because I've also heard him described as kind of a troublemaker, kind of a jokester, a little bit. So yeah, he may or may not have named a turtle after his boyfriend's rear end.
He definitely sounds like a jokester in the fact that he found himself funny. Most of it, like, he seems like one of those people.
Yeah. I said laugh. The two men spent nearly 30 years together.
Wow.
They met in 1906, and then they traveled together, and they were together until their deaths.
Mm-hmm.
More on that later.
I was about to say, I seem to remember you mentioning
I mentioned, yeah.
a particular note that takes two people.
Also, during their travels around Albania, while they're finding fossils and finding geology, they are caught up in war. This period of time saw a series of uprisings in Albania. In the early 1900s, Albania was seeking independence from the remains of the Ottoman Empire.
Gotcha.
So formerly under the Ottoman Empire, I think I remember seeing that it was the last country to gain independence from the Ottoman Empire. So there were a series of uprisings during that time, then the Balkan Wars, then World War I. And these two men were there for the whole thing. Nopcsa was a major proponent of Albanian independence. He wanted to help, right? He saw himself, he really identified with this place. He wanted them to become independent under the umbrella of the Austro-Hungarian Empire, which was where, of course, he was from.
Yes.
He ended up creating critical cultural and geographical maps of the region, which became important during wartime. Twice he put his name forward to become king of Albania after it gained independence.
If you're considering submissions.
Yeah, that's basically, apparently he was like, Albania's going to need a king. I think it should be someone from the empire they're going to be part of. Not naming any names, but me.
Yeah.
Also, he may or may not, while traveling around Albania, taking lots of photos, documenting the geography and the culture and the geology, have been also reporting all that information back home as a spy.
Yep.
Under the guise of a scholar. Or, as one article I read put it, or perhaps being a scholar under the guise of a spy. Depending on which one he was actually most interested in.
Yeah, exactly.
Again, I've seen conflicting reports as to whether or not he actually was conducting espionage in Albania. But I have seen less conflicting reports about his time as a spy in Romania during World War I, where he apparently lived disguised as a shepherd among shepherds for a year. While reporting information about troop movements back home. During the war, he led espionage missions. He rounded up, gathered Albanian troops and convinced them to join him in battle. He wrote letters with invisible ink, messages between the lines to send back to people. He was James Bond for a while in World War I.
Wow. I was just about to make a comment of it's debated whether or not he was doing espionage as he was touring the countryside and mountains of Albania. And I was like, well, yeah, we think about the fact that once the war's over, we get to find out all the cool spy stories, but there's probably hundreds of spies, that we'll never know about because they took that to their grave because they were a spy.
Yep. Apparently not this guy.
But this is one where it's no, and here's everything he did.
And then there is another story. This one, I've seen this referenced in 3 places. One of them's Wikipedia referencing one of the other places, and the third place says go to Google and you'll find this. So I've only seen this in one place, and I don't know how reliable a source this is. But you will hear sometimes that there is a story of while he was trying to leave the shortly lived Hungarian Soviet Republic after World War I, he got on an airplane and then took out his gun and threatened the pilot, making him fly where he wanted to go, effectively hijacking the plane.
Yep.
Which, in the one reference that I don't know where the information comes from, claims that this makes him the first person known to hijack an airplane. I don't know how you would confirm that.
Yeah.
I'm not sure that I believe that after World War I was the first time someone hijacked an airplane.
Yeah, it's in a war that used planes.
Right. So I don't know that I believe that he was the first, and I guess I believe that he hijacked the plane, but I wanted to mention it.
Yes.
Because so much of this man's story is lore.
Yep.
It's pretty fantastic.
Well, and I wonder, because there's a difference between crimes during war and outside, is that because a soldier hijacking a plane is not considered the same way as a civilian.
Right.
And so I wonder if this is the first civilian hijacking.
Funnily enough, that's going to come up here in a second. After the war, he ended up leaving Albania and leaving his homeland. Because after the war, Transylvania was taken over by Romania.
Oh.
Formerly Austro-Hungarian, it was taken over by Romania, which is where it is now. And when that happened, Nopcsa's estate and fortune were confiscated.
That's often what happens.
They took all his stuff. Apparently, I heard in one place he was declared a criminal of war, but then pardoned. He ended up selling his collection of Transylvanian fossils to the Museum of Natural History in London. And then he had to do a thing that he had never had to do in his, at that point, 30-ish years of life. He had to get a job.
Yep.
So he and Dota moved to Vienna, got jobs, and devoted themselves for a while to scholarship. For a few years, he was the director of the Hungarian Institute of Geology, before apparently he was forced to leave because people didn't like him. And that's where they stayed effectively. That's what they were doing for the rest of their lives there, during which time he did a whole lot of scholarly work. After the break, we'll go into a little more detail in what he did in terms of paleontology and sort of what his legacy as a scholar is. So after the break, it's going to get way less cinematic.
Way less wacky.
We're going to talk about science for a while.
It's not as many fossil shenanigans in this part as like the Bone Wars, I assume.
Right, yeah, no, we're done with the Bone Wars part of this particular story. But I've teased how it ends, which is dramatic and ridiculous. So this was a very eccentric, notable, well-traveled, adventurous man. After the break, we'll talk about the science he did. Much of Nopcsa's paleontological work took place in the first 3 decades of the 1900s, which means he was doing this work at the same time as a lot of the other early 1900s scholars of paleontology and evolution. He was a pretty major name in this time of development of paleontology as we know it.
Yeah, where a lot of the foundation was being laid down.
Over his life, he published 101 papers on paleontology.
That's not nothing.
As I mentioned before, he named 25 species of extinct reptiles from the Mesozoic, which I think is in addition to his 5 dinosaurs.
Oh, wow.
Most of these from the Cretaceous of Transylvania. I have heard him described, I've read him described, as one of the first great theorists in vertebrate paleontology. His work was predominantly on dinosaurs, but he also did pterosaurs, crocs,
Woo!
lepidosaurs,
Woo!
That's right, turtles, amphibians, and all sorts of other things. I found a paper from the 80s that goes through the works of Nopcsa, which is super cool. That'll be linked in the blog post.
Nice.
That goes through a lot of what he did. So for this section of the episode, I want to go through some of the major areas where he helped sort of lay the foundation for ideas in paleontology. The thing he is probably the most famous for is describing the dinosaurs of Transylvania and their unusual features. Astute listeners may remember we've talked about dinosaurs from Transylvania before. The area that we now know was once Hat's Egg Island. Nopcsa described dinosaurs from that area, including his hadrosaur, Telmatosaurus, which was about 5 meters long, 15 to 20 feet. Struthiosaurus, that nodosaur that Bayezid discovered, which was, I think, one of the smallest ankylosaurs at about 2 meters. And very famously, a taxon he named, I think he named it Titanosaurus, but was later renamed to Megarosaurus, a 6 meter long sauropod. dwarf dinosaurs.
Yes.
He was the first person to do research into the dwarf dinosaurs of Transylvania. He noted in his writings their unusually small size. He recognized that they were small relatives of larger descendants. Or ancestors, right? They were descendants of ancestors who were larger, that these were unusual for their size. This led him to hypothesize that this area was once an island.
Island dwarfism.
And as he reasoned, with limited resources, you might be driven towards dwarfed size, which, we talked about island dwarfism way back in episode 4.
Yep.
But at this time, that wasn't a thing people were on the lookout for. I think, if I remember correctly, our modern idea of island dwarfing is from later in the 1900s. So he was one of the first people to talk about it, and he was absolutely the first person to talk about it in dinosaurs.
Well, and that's what I was about to say so he was one of the first people to talk about it, and he wasn't doing it looking at an island full of animals.
Mm-hmm.
He was doing it looking at tiny dinosaurs. That's impressive. That's an impressive logical path to reach that conclusion. Wow.
Yeah, so he really sort of pioneered this concept of identifying insularity, right? Island effects in the fossil record of dinosaurs. Now, that idea for a long time went sort of taken for granted, but back in 2010, newer research looked into it and has essentially confirmed this idea.
Yeah.
And said, 100 years later, it looks like he was right. These are dwarfs. The area is now known as the ancient island of Hatzeg. Hatzeg Island, it's also the Siebenbergen region in Romania, so I've seen it referred to as the Siebenbergen Island. It's home to dwarf dinosaurs, but in addition to that, we have since found possibly flightless birds, and the giant pterosaur Hatzegopteryx.
I was about to say, this is where Hatzegopteryx is from.
Yeah, named for Hatzeg, the island.
Yep, where we think it might have been stalking around and eating dwarf dinosaurs.
Yeah. Nopcsa was the first one to give us a look into this ancient island ecosystem in Transylvania.
That's a pretty significant claim to fame. That's pretty cool.
Which is pretty cool. Another thing that he gets a lot of credit for is for being one of the first paleontologists to really focus on non-fossilized things. Soft tissue, physiology, behavior. He is notable for having made it a habit of comparing ancient species with living species to get information about soft tissues, muscles, glands, organs, sometimes even brain tissue. He was trying to infer soft tissue and physiology, and from there sometimes behavior from just the bones. He referred to it apparently as paleophysiology, which today I think we'd more likely use the term paleobiology.
Yes.
Trying to understand the biology of these creatures.
And that's one of those where that's a given in modern.
Yeah, nowadays that's just what we do.
We find a fossil animal. Okay, well, what does it look like today? Go into collections and look in the lizard drawers.
Right, exactly.
Which lizard do we have today?
Go dissect this animal to learn information to help us with the fossils.
Yeah, that's standard practice, but at one point it was not.
No, and apparently he was one of the first to pioneer this technique. He studied, for example, dinosaur jaw motion. So he did some research trying to understand how the jaw would have moved.
How they would have chewed.
Particularly in hadrosaurs. And apparently he kicked off debates about hadrosaur jaw motion. Apparently this was a thing early paleontologists debated about. He also did some research where he was linking body size to the inferred size of the pituitary glands.
Oh.
Before we knew about growth hormones.
Oh.
Released by the pituitary gland.
What?
And apparently he also made some very early suggestions about possible warm-bloodedness in Mesozoic reptiles.
That's also very impressive.
So he was very forward-thinking in this idea of dinosaurs and other animals as sort of living, functioning, biological...
As animals.
As animals.
Not as these ancient mysterious creatures, but as old, now dead animals.
Yeah.
And that is a very crucial shift that paleontology had to take to be modern paleontology.
Yeah. It's fun. Well, it's funny because, like you said, these are things that, we kind of just do nowadays.
Yeah, like dinosaur documentaries these days are shot and shown very similar to Planet Earth,
Right.
where it's shown like an animal documentary with some, a bit of embellishment, a bit of doing up the drama, but yeah. But for a long time, that was not necessarily the common way to view these creatures.
Yeah, if you look back at some of the earliest paleontologists, they're not necessarily looking much beyond the bones.
Mm-hmm.
The documentary that I watched, one of the people in there also claimed that he was one of the first paleontologists to make it a habit of drawing the dinosaurs as they would have appeared in life. And more specifically, that he would make, like, flip book style animations
What?
to depict their motion, like how they might have moved.
I vote researchers
Make
today
flip
start putting those in your publications, please.
Now-
like the corners of the Animorphs book at the
Yeah,
bottom of every
exactly.
page.
Every
I want
paper,
and so that when I print it out, I can.
you flip through it.
I want this.
Yeah, I haven't seen many representations of those. So again, I've heard that he did that, which is very cool, and I hope it is true.
Yes.
And along those same lines of imagining these animals as animals, sort of in all of the things that come with that beyond the bones, he was also one of the first paleontologists to try to identify signs of sexual dimorphism in fossils, particularly dinosaurs. So we've talked about sexual dimorphism before, where males and females of a species will have distinct differences.
Mm-hmm.
We've also talked before about how sexual dimorphism in dinosaurs is one of these major elusive questions in dinosaur paleontology, where we keep trying to find it and oftentimes not succeeding.
Yep, because you can bump into the dual question of, is this a species with two very sexually dimorphic male and females, or are these two different dinosaurs
Right.
that may be closely related?
Yep. And you run into the issue of, is this just variation within this species, or are there actually two different... It's very difficult to tell. Nopcsa tried to do it. He looked at skull shape, he looked at leg proportions. In at least one case, he would also examine the hip bones of dinosaurs to look for signs of genital musculature.
Oh.
It's like, can I get a sense of what soft tissue and muscle was here, and can that tell me about the genitalia of this individual, which can then help me identify male versus female.
Yeah.
So he was one of the first to point out that what you were saying, some species might actually just be different sexes of another species, that we have to look out for the differences between male versus female when trying to identify species to species. And he wrote quite a bit about this question of sexual dimorphism in dinosaurs. Now, this is a point where I will say a thing that should not be at all surprising, given that we're talking about someone from the early 1900s. Basically everything he tried to do to differentiate male versus female in fossils was wrong.
Yeah.
He didn't succeed at it.
No.
He wrote a lot about it, but his techniques don't hold up. Some of his supposed male-female pairs either aren't, for various reasons related to the features he was looking at, or weren't actually contemporaneous. In some cases, he was looking at different species and mistaking them as dimorphism. So while he was an early theorist on the subject of sexual dimorphism, he didn't really succeed in giving us any methodologies.
Yeah, he wasn't forming the foundation of our knowledge about it.
But he did help form the foundation of our thinking about it.
Yes.
He also was one of the first to propose social behavior in dinosaurs. He suggested that the crests of hadrosaurs may have been sexual selection. He argued that dinosaurs may have been doing display or had social hierarchy. He was an early proponent of the idea of parental care in dinosaurs.
Nice.
60 years or so before we found nesting grounds of dinosaurs actually in the fossil record.
Very cool.
One methodology that he did engage in that does survive to this day is that he did histology.
Oh.
He would take thin sections of dinosaur bone so that he could examine the internal structure of the bone to get a sense of how the structure varied from specimen to specimen.
Huh. That's not what I was expecting you to say.
Yeah. And I don't know that he was the first to do it, but certainly among the first
An
to do
early
it.
adopter.
He apparently had a collection of over 500 histologic slides of fossils.
Wow.
Which sadly, from what I've read, is lost now. We don't know what happened to it. It's a real shame.
That one hurt. That's real sad.
Now, early in his histological analyses, so we use histology these days to look at like growth patterns and the structure of the bone. Early on, he tried to use it to see if he could identify different species that way.
Interesting.
Right, so if you only have a fragment of bone, can I look at the internal structure of the bone to tell different types of dinosaurs apart?
Yeah, is there something indicative of different species by the way the bones put together?
Which was not successful. That didn't work. But then later, he got in the habit of using histology to tell adults from juveniles.
There you go.
Which we do still do today. Absolutely. And apparently he also either did or attempted to correct some mistaken identifications. This isn't a new taxon. It's just juvenile of this other thing. Yeah, which is also something we still do today.
Yep. Yeah, I mean, because if listeners think back through all the newses where we talked about growth in a dinosaur or fossil species, histology almost always comes up in those.
Absolutely, because that's how we're looking at it.
That's pretty awesome.
And speaking of being a bit ahead of his time, he also speculated on the origins of bird flight. Now, back then, the prevailing idea of how birds came to be, first of all, we did not know where they came from.
Mm-hmm.
The idea that birds evolved within dinosaurs really didn't take hold until the 1960s into the 70s. But there were some people suggesting where they might have come from. And back then, the prevailing idea is that wherever birds came from, they probably evolved from the trees.
Mm-hmm.
Right? We talked back in episode 37, and I think also in episode 6, about these competing hypotheses of ground up versus trees down for flight origins in birds, also bats and pterosaurs. Well, Nopcsa was a proponent for a cursorial origin of bird flight. Running.
Yeah.
He suggested that you could have had small bipedal running ancestors that benefited from being able to jump, and that's where flight may have gotten its kickstart, is in jumping, running small animals. Where it may have taken off. He is often credited, I've seen him credited with being an early proponent of dinosaurs as the ancestors of birds, but I've also seen other places that suggest that he was a bit more vague about it, that he wasn't necessarily saying dinosaurs, but just small bipedal early reptiles.
Yeah.
So he may or may not have actually said,
hit upon,
I think dinosaurs came from birds. If he had, he wouldn't have been the first one. We talked about Marsh. I think we mentioned this back in the Bone Wars episode in 58, that Marsh was one of those who was suggesting birds might be a link to dinosaurs. But these days, the trees down hypothesis is not nearly so clear-cut.
Yeah.
Right? The ground-up idea is certainly plausible, and Nopcsa was an early suggester of that.
Yeah, that's definitely where I see, like, when I see it come up, I tend to see most of the conversation
Same.
leaning that way, or at least discussing that a bit more heavily.
Yeah.
That's well done.
Yeah. On the note of birds, he also argued way back then that feathers might have originated as insulation.
Nice.
Another idea that is a very modern idea that still is widely considered probably accurate today.
Well, and it makes sense since you mentioned he had proposed or messed with the idea of warm-bloodedness.
Yes.
In Mesozoic reptiles, that he would go, well, hey, if they're warm-blooded,
they're feathers.
Some fuzz would help.
Speaking of evolution, he was also involved in early scholarly discussions on evolution and how evolution worked. He wrote a bit about where evolutionary processes might originate and how you get change. Because again, remember, this is pre-modern synthesis. The scientific community had not yet settled on our modern understanding of how evolution works.
Yeah.
His approach when it came to evolutionary discussion was to focus on physiology, right? The soft tissue, the internal processes. He apparently looked a lot at pathologies. So, when things go wrong, and internal body processes to explore how new features might come about or what the limitations on new features might be.
Okay.
He was really coming at it from this is how the body functions.
So how could something new pop up within this functioning system?
Exactly, the same way he was doing it with his fossil studies. And I've heard that as a major praise of his work, that he was very interdisciplinary.
Yeah.
He taught himself paleontology and anatomy and physiology, and then was pulling from all these different areas to try to answer these questions. Much like Darwin, really,
yes.
in the ways that we talked about him.
Well, and that's a common theme among a lot of either renowned scientists or breakthroughs in scientists is when information from more than one source,
right?
Because that's when you get good pictures of stuff.
Yeah. Now, I don't want to give the impression here that he was just right about a bunch of stuff, because his ideas about evolution were also wrong.
Oh yeah, like that's he's was a good thinker in these topics, but that doesn't mean he was breaking open the mysteries left and right.
Nopcsa's evolutionary ideas were much more Lamarckian than Darwinian. So his, if I understood correctly what I was reading, hinged still on inheritance of acquired characteristics. So he hadn't quite, he wasn't quite at the evolution as we know it. And of course he was struggling under the same problem that all those early evolutionary theorists did, is that they didn't know about genetics.
Yeah, no DNA.
They were missing a huge piece of the puzzle.
Yeah, I wondered if that's the angle he was coming at it from when you said pathologies.
Yes.
That injuries being a way, injuries and healing from them being a way to look at how we could develop new features.
Right. Or even even if not necessarily injuries, but defects.
Yes. Yep.
He also looked at I put down the word pathology, but another word in that same sentence in that article was teratology.
Oh.
Which is, when incorrect development.
Yeah, when something develops
birth defects. And
such. Which is a very on path to a very Lamarckian view that this baby was born with a horn, and then this species developed horns.
Right. Something went wrong.
Mm-hmm.
And then, of course, the other area that he made big contributions was in geology. The last thing he wrote was a 600-plus page paper on the geology and geography of northern Albania. He did a ton of writing on the geology of that region. He also was a proponent of continental drift, back at a time where no one was a proponent of continental drift. He would point out evidence and say, hey, this seems to match what that Wegener guy is saying. He didn't agree with everything of Wegener's, apparently, but not only did he sort of support this idea of, the continents move, but he would link that theoretical movement to the distributions of fossils. Nice. And he'd say, the changing landscape of our changing geological landscape might impact why we find certain fossils in certain places, which again is a very modern day idea.
Yeah.
And again, he wasn't the only one saying things like that.
He didn't come up with the idea of continental drift.
But he was a proponent of it decades before it finally, the more accurate version of it.
So he was into it before it was popular.
Absolutely. So over the course of his life, he published some 150 to 200 works, lots of paleo, also geology, evolutionary science, cultural things. He really was an impressive scholar.
Yes.
And he interacted with a lot of other scholars of his time. He seemingly was a fairly well-respected. He was invited to give talks places. He may have been arrogant and sounds like a jerk.
Yep.
Often enough that people noted it.
Yeah, that it's now part of history.
Yeah. But, he did a lot of really exciting work that laid the foundations for a lot of what we do today, but that doesn't necessarily get a lot of attention in our modern times. But, of course, this story does have dramatic ending.
Mm-hmm.
Later in life, apparently, Nopcsa suffered what he called in his memoirs shattered nerves, and I've heard people relate this to he had a real rough time after the war. He lost all his things. Apparently, he got into a fight with some villagers at one point where he was heavily injured.
Oh wow!
So he called it shattered nerves, which I've heard some suggest that today we might describe as some sort of depression of an emotional issue that he was having.
Yeah, I wonder if some form of PTSD or something like that.
Could be,
Yeah.
Or it could also have been related to injuries.
Yep.
Right? It could have been a neurological thing.
Yeah, exactly.
He had something...
That he was concussed at some point, and no
Right.
one knew what to call that.
So he really struggled later in life. Dota, his partner, apparently became an alcoholic.
Ooh.
Later on. It seems like the two of them might have... They still lived together, but they may have been more separated later in life. So his later years, he's still doing work, he's still publishing, but it seems like they were really struggling in those later years. And then they died in a much written about event. In fact, this is one of the most famous things about him.
Yeah.
Is that the two of them died together in a murder-suicide. And I was talking to a friend of mine about this the other day, and I said, I'm reading about this guy, and he died in a murder-suicide. And she said, which one was he?
Yep. That's the question.
And there's not a good answer.
Mm-mm.
There's not like a good option, but there is a worse option. And he's the worse option.
Yep. Which also, from the other things about, does not super surprise me.
On April 25th, 1933, at his home in Vienna, Nopcsa prepared his affairs and then put sleeping powder in Bayezid's tea and then shot him in the head and then shot himself. And that was the end of Nopcsa and Dota's story together. He left behind a note, and the note said the following. The motive for my suicide is my nervous system, which is at its end. The fact that I killed my long-term friend and secretary, Mr. Bayezid Elmas Dota, in his sleep, without him having an inkling as to what was going on, was because I did not want to leave him behind, sick, in misery, and in poverty, because he could have suffered too much.
Huh.
Which is one of those notes that is easy to read and go, oh, well, it was, he was compassionate and he was sympathetic, but,
yeah, here's the logic behind
logic
me killing
behind
you.
why
Yeah.
This was, again, like I said, widely reported.
Mm-hmm.
That note exists through police reports from the time. We know the details of what happened because of police reports from the time. One positive thing that he did in the midst of that is that he left instructions for his works to be redistributed. So his paleontology manuscripts were donated to the London Museum. His Albanian work ended up going to a specialist on Albanian studies. Like I said before, 150 or so of his photographs survived originally in Budapest. Now I think they're in Berlin. Mm-hmm. His library was eventually sold off. So his work kind of scattered after his death and was distributed to various different places. I read one last alleged story about this man. I read in one article, and I don't know where this information came from, I read that he supposedly demanded to be cremated in his motorcycle gear.
Once again, I couldn't have predicted.
Because he was a character.
Yeah.
And thus ends the story, the wild tale of Baron Franz Nopcsa. I've seen some discussion about why his legacy is the way it is.
Yeah.
You know, there is this question that I've seen raised of, people don't talk about him very much. There's a lot of famous names in early paleontology, and his really isn't one of them, despite the fact that he really did a lot of exciting, ahead of his time kinds of research.
Yeah, that from a research point of view really should be up in those higher echelons of names that we are referencing.
And I've seen some suggestions that maybe it has to do with his homosexuality, that particularly in his area maybe he wasn't given the appreciation afterwards, even still to today, where in some places that's not Some places don't want to have a local hero who also happens to be gay.
Yeah, or to be naming a wing of the museum or something.
Right.
Yeah.
So unfortunately, that could be a reason.
That is a good point.
I wondered at first if maybe he just didn't write a lot in languages that were widely circulated.
Oh, yeah.
But it sounds like he did. It sounds like he had a lot of correspondences with other well-known scholars. So I don't think there's a solid answer to why he's not widely talked about. It wouldn't surprise me if the specter of the circumstances of his death and the circumstances of some of his life kind of gets in the way of his legacy a bit. Because a lot of what you read about him, that's what they start. They'll start with, he was a spy and he was eccentric and he would go disguised as a peasant and he would do this and this. And then he had a tragic death before they get to the paleontology stuff.
Yeah, well, that's the hooking, part of his story.
And while all of that is exciting
and true, that's a valid part of his story.
Absolutely. It's not all noble.
No. And that's something that I've been mindful of while doing this episode, is that it is often something that I try to keep in mind when discussing or learning about historical figures, is acknowledging the fact that they may have done many great things, or many things that we are now thankful that they did, but that does not necessarily negate or make it worth ignoring if they were a jerk.
Right.
Or an openly bad person in some cases.
Right. Well, we talked in the Bone Wars episode 58 about Martian Cope.
Yeah.
And that, those two guys did a lot of really great stuff for early paleontology, and they were also huge jerks. And they were terrible.
In paleo communities, those names are not heralded. They're not mentioned and brought up in reverence typically, but more infamy.
Right.
Those are examples of famous early paleontologists that, yes, did some good work, but that are bad examples, that you should not be like these paleontologists.
And there's and unfortunately a lot of the famous names, because they were notable and because they did a lot of work, they became famous despite their infamy.
Yep.
Whereas the less infamous ones also aren't famous.
Which
a lot of names get sort of overlooked. Which, unfortunately, is still the case today. There are problematic people in all sorts of fields that get more attention than they really should.
I mean, and I think it's worth saying that I think that's part of the reason they do, is because they're more exciting.
Oh, yeah,
they're
absolutely.
more intriguing. Their story, regardless of how you spin it, is more interesting than a well-meaning... well-behaved, noble, good scientist.
Right.
Because it's not as often that those are going off on wacky adventures, because wacky adventures often start with you doing something bad or stupid.
Right. And they're not in the newspaper for being spies or dying tragically.
Yeah, after you kill your lover. And so it makes me think of a post I saw, which was just a post about artists in the modern day Hollywood, and basically saying that they were rejecting that mentality that these toxic directors or actors or writers are should get a pass because of how brilliant they are. Right. That the toxicity kind of just goes along with genius, and that you just kind of have to take the good with the bad.
Right. And
basically they were saying, no, there are just as many brilliant, good, nice people if we just give them a chance, and if we stop pandering to these toxic people, it will make room for the less toxic people. Yeah. And I kind of have that thought with famous scientists a lot of time, where we herald it as like, well, yeah, they did some questionable stuff, but look at all the stuff they did. All right, that's not to say someone else wouldn't have done that stuff.
And one of the references that I looked at for this episode that I was reading through, I don't remember the specifics of this passage because I went past it pretty quick, but it sounded to me like they were doing that. Mm-hmm. Like they were saying, well, yeah, this guy gets criticized. Nopcsa gets criticized for a bunch of things, but you have to understand.
Yeah, exactly.
And I think they were saying like, oh, he's called arrogant, but you have to understand he was a noble and he was a genius, that level of intellect. And it's like, yeah, but no, that's not really an excuse.
It's not an excuse. And also the term genius is a problematic and often misused term. Like, There's no research I know of that's just like, yeah, some people are just born brilliant. No, that's not how it works.
So this is this character is a fascinating, interesting, clearly flawed,
complicated and
clearly talented.
Mm-hmm.
And it's been really a lot of fun to read about him and to recount his life and to marvel at this almost unreal story of this person who, while doing all of that unreal stuff, also helped lay the foundation for paleontology. Yeah. So this is just a really fascinating, notable, significant figure in paleontology. And I had fun learning about him.
Mm-hmm, mm-hmm.
I'm sure there will be more requests for similarly interesting characters in the future. So like we said, send in requests if there's more people you want us to talk about. We will certainly put them on the list.
Well, and because this was a fun dive into a topic we don't typically dive into, especially because, as you pointed out right before we started recording, every other time we've done this, we had someone else
we had guests
to guide us through it. So it's fun. It's fun to take a dive into the history of a human.
Yeah, and like I said, I found a bunch of cool articles, references, one paper about his work, and a documentary about his life. And we'll link to all those in the blog post, so keep an eye out for that. Before we go, we have a patron question.
Indeed we do.
One of the things patrons get to do at a certain level, as a reward for supporting us, is ask us questions for us to answer right here on the podcast. Will, would you like to share with us today's patron question?
Indeed. Our question today is from Clara, who asks, why are, in quotes, complex tetrapods, mammals and archosaurs, unable to do certain things that more, in quotes, primitive tetrapods do, amphibians and squamates? Examples: metamorphosis, producing toxins, changing colors, regrowing lost limbs. Am I just subconsciously cherry-picking examples, or is there a reason for this trend, or is it just coincidence?
Good question.
Yes, very good question.
So, yeah, you did that split between so-called complex vertebrates versus lower vertebrates.
We happen to be part of the complex one, don't we?
Imagine that.
Weird how that worked out.
Does seem to also separate us from some of those cool superpowers that those other animals have. So I think that there's a couple of angles to answer this question. And I think one of the first ones is, Clara, you're definitely cherry-picking some examples.
Yes.
There are all sorts of cool things that us complex tetrapods can do that you don't see in the lower, the lower tetrapods. You know, true complex endothermy.
Yep.
Much more common in archosaurs and mammals. Archosaurs and mammals share the amniotic egg, which you also get in some others, but complex birthing procedures, parental care, the largest and fastest animals ever are in those groups. So it's not just that, we're boring.
Yeah, it's not that we're just have lost cool traits.
But you're also not wrong that there are absolutely things that it seems have been lost as you get higher, more advanced.
That you have to leave behind.
To be so cool as we are. We don't metamorphose. We don't do color changing in mammals and archosaurs. Regeneration is almost unheard of.
That's a big one. That is something that is extremely rare or limited in our groups and ridiculous in some of the more primitive.
Fish amphibians are great at regeneration.
It's insane.
Squamates are pretty good at it. And the answer is that's not a coincidence. Why that is the case is not clear cut, but I've seen lots of discussions about. So, for example, with regeneration, archosaurs and mammals tend to have physiology that is different from those other animals.
Yes.
The physiology that allows us to have high body temperatures, high metabolisms, complex immune systems might also make it much harder to fully regenerate limbs.
Yeah.
Right? The nature of our immune system might be getting in the way of that. When it comes to something like metamorphosis, it could be a similar story. There are certain complexities in mammal and archosaur bodies that aren't present in amphibians and fish that might get in the way of that metamorphosing process.
That might be too complex for one of these animals, one of us, to develop via metamorphosis after we've already been born.
Right. Well, and it makes me think of teeth.
Yeah.
You know, mammal teeth are super specialized.
Very specific.
Come in all sorts of extreme, almost unheard of shapes and sizes. But the trade-off is most mammals, you only get 2 sets.
And while like a frog can develop stuff like that during metamorphosis, to develop something this precise in such a short period of development would be, it as far as I'm aware, kind of unheard of in the animal kingdom. Like,
I think so.
That's lots of very specific moving parts that you need to develop into place just right.
So to attain the features that are that have given us and birds the supposed title of higher vertebrates, advanced, complex, those features that have gotten those names bounced around are associated with trade-offs that probably mean leaving behind some of those older characteristics. The color changing thing is interesting because it makes me think most animals that do advanced color changing, it's what skin cells are doing.
Yes, exactly.
It's happening in the skin cells, and mammals and birds are covered in other stuff.
Yep.
So it could very well just be that, oh yeah, it's just it's much harder or maybe even impossible to do that with your fur and feathers.
Well, and that's what I was going to say is that hair and feathers are not living tissue.
Exactly. There's no cells to make change in there.
You'd have to have like hollow structures that you can pump colors into.
Right, like a fiber optics.
Yeah, exactly. That you're like, I'm changing the fluid inside my hair from this color to this color.
Yeah.
So, something weird like that. So it may just be that we don't use that because it would not be practical for us. Not so much that we can't,
right?
But there's no reason for me to change my skin color if I'm covered in black fur. You know.
So some of the things that are different are probably coincidence. Like there are certain, like it might not be that fur, for example, there might not be like a specific reason that amphibians don't have that. They just don't. But other things, absolutely, it's not a coincidence. There are trade-offs associated with being this awesome that you just can't do those other things.
And while we've been emphasizing that the quotes around complex and primitive, like we've mentioned with other things, complex does not necessarily mean better.
Right.
Like, I can have a more complex car and it not be as good at getting me from A to B as a more primitive car if it breaks down more easily.
Yeah.
You know, so the term complex means that there are certain systems and layers of systems in mammals and archosaurs that we don't typically see in the other groups. That doesn't mean we're superior animals.
Right. And every time you develop something new and cool, there's trade-offs.
Yes.
You know, flying animals can do something that is ridiculous.
Is a superpower according to almost every other group you ask.
Yep, superpower. But boy, does it limit what else they can do.
But man, your bones better be lightweight.
Your body has to be a certain shape.
And your breastbone's got to be huge.
Right. There are no known burrowing and deep diving are not known very commonly in flighted groups of animals.
Yeah, exactly.
So it's a really cool question, and the answer is that there are tons of answers, but the short answer is nope, not a coincidence.
No.
Trade-offs of evolutionary novelties.
And some we have better ideas for why it's there, others we don't. We can't fully answer why, and that's actually very exciting to me.
So thanks for that question, Clara. Thanks to our requesters for requesting this episode. Thanks to all of our new patrons. Thanks to all of our old patrons.
Always.
Thanks to all of our listeners in general for listening, supporting. We hope you've enjoyed this episode. We will be back in a fortnight, like we always are. In the meantime, check out our blog post. There'll be pictures and lots of links to the places where I found fun information about Nopcsa. Follow us on the social medias. Send us requests for more episodes. And until then, sit around and wait for us to come back, I guess.
Yeah, I mean, that's what I do.
Yeah.
I sit here at the mic, and then David comes in and goes, "You ready for an episode?" I go, "Oh, good."
Oh boy, is it time. All right, everybody. Enjoy your Darwin Day. Celebrate however you see fit. Go outside.
Celebrate with all the traditional Darwin Day customs.
Foods.
You all know them. We don't have to explain them.
Make your Darwin Day meal.
Yep.
Roast finch.
Yep. Decorate the Darwin tree.
That's Go outside and watch birds and butterflies for a while.
Yes.
Buy a carnivorous plant.
Go catch a beetle.
Go put a beetle in your mouth.
Go put a beetle in your mouth. As to celebrate Darwin Day, as is tradition.
As is tradition. Goodbye, everybody.
See ya.
Thanks for listening to the Common Descent podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.